Hello again. This is the foundation mastery method for differential equation. In this lecture, we'll be talking about the conversion of piecewise defined function to the step function or Heaviside function, and then few examples of Laplace transform. Convert a piecewise defined function to its step function form. The piecewise defined function is given below as an example. Ft is 0, 7 and 5 times t minus 3. So 0 is given when t is less than 1. 7 is when t is greater or equal to 1 but less than 8. And it is 5 times t minus 3 when t is greater or equal to 8. To find the step function or the Heaviside function, we take the number line, and in the number line we'll put t values which is defined critically at 1 and 8, so we'll mark them 1 and 8. And then the values we have when t is less than 1 is 0, t is between 1 and 8 is 7, and then t greater or equal to 8 is 5 times t minus 3, we put it here. Okay, now at 1 we write our step function is ut minus 1 and 8 ut minus 8. Now what are the multiples? And we determine like this: ft equals ut minus 1, and then the multiple will be right hand value and left hand value of 1. So we say 7 minus 0 plus ut minus 8, and then we are getting 5 times t minus 3 minus 7. And after simplification we get ft equals 7 times ut minus 1 plus 5t minus 22 ut minus 8. Let us look at some basic definitions, and here we start with Laplace transform of a function ft, which is defined as an improper integral 0 to infinity e to the minus st ft dt. And since the limit goes on t, so the function will come out as a function of s. That's why we write it uppercase fs. Few basic formulas. Let me take or find the Laplace transform of e to the at. So in our formula we'll replace ft by e to the at. That we did here. Now when I combine the terms, and since it is improper integral, we take as a limit b goes to infinity and infinity replaced by b. So e to the negative st, e to the at. Now we'll combine it. So keep your t outside and the negative sign also preserved. So then inside will be s minus a. Now the integral of e to the negative s minus a times t is very simple. E to the whatever exponent you have divided by that one. So negative s minus a, you divide by that. You understand this integral, I'm sure. Now we plug the limits. Upper limit first, b for t, and then 0 for t. Now when you take the limit b approaches infinity, we have here e to the negative. So this term actually goes to 0. First term goes to 0. And the second term is simply, the numerator is just 1, and the denominator you have a negative and also a negative there. That will make it positive. So you get 1 over s minus a. So this is the basic of e to the at Laplace transform. In the next example I will be using the same. I just replace here at by something else and we'll see what it is. Okay, so the formula we mentioned one more time. Laplace transform of e to the at is 1 over s minus a. Next example, we want to find formulas for cosine bt and sine bt. Okay, so remember the Euler function for the complex variable e to the ibt equals cosine bt plus I sine bt. So we'll take the Laplace transform of e to the ibt. So again, the function we had ft was e to the at before. Now we just replace a by ibt. So then the answer is also follows through. It will be 1 over s minus ib because we replace a by ib. Now this is a complex number. The left side we can separate because e to the ibt is cosine bt plus I sine bt. And on the right hand side I have 1 over s minus ib. So we want to write this on as a complex number standard form, a plus ib kind of. So that's why s minus ib is conjugate. We multiply in the numerator and denominator, so that my denominator will be a real number that you see here, s square plus b square. In the top I have s plus ib. And now Laplace transform cosine bt, we can take I outside, and the Laplace transform of sine bt. So this gives me separate real part s over s square plus b square plus I times b over s square plus b squared. So now this one is suggesting us that real part will be same and imaginary will be same. So then we can say Laplace transform of cosine bt is s over s squared plus b squared, and Laplace transform of sine bt will be b over s squared plus b squared. Thank you.